You open your eyes. The first thing you do is look for the sun. You look because on every other planet you have been to, the sun was there. Overwhelming on Mercury, hidden behind clouds on Venus, small but present on Mars, a bright star in the rings of Saturn, barely visible but findable on Uranus. You find it here. It takes a moment. You have to know where to look. The sun from Neptune is not a disk. It is a point, a very bright point, brighter than any star, but a point. A single bright dot in a sky full of other dots, distinguished from the stars only by its specific brightness, by the faint corona around it if you look carefully, by the fact that you know which direction to look. That is the sun. That bright point is the thing that runs the solar system. The thing that Mercury was trying to escape from. That warmed the Martian afternoon. That you could not look at directly from Saturn's rings. From here, it is a point of light. You are 4.5 billion kilometers from home. The light you are seeing left that point 4 hours and 10 minutes ago. You are so far away that the sun's light is old by the time it reaches you. Below you, the atmosphere of Neptune moves. Not gently, not slowly. The wind here is the fastest sustained wind in the solar system, 2,100 kilometers per hour, and it is already finding you. Neptune is the last planet, not the last object in the solar system. Beyond Neptune there is Pluto and the Kuiper Belt and the Oort cloud and the slow thinning of the sun's influence over trillions of kilometers until eventually the solar system simply ends and interstellar space begins. But Neptune is the last planet, the last large body, the boundary marker. Everything inside Neptune's orbit is the solar system in its familiar form. Everything outside is the frontier, the cold and empty outer reaches where objects are small and dark and widely spaced, and the sun is a star among other stars. Neptune sits at that boundary, and Neptune is a mystery in the same way Uranus is a mystery, but the mystery is different. Uranus is cold and quiet and passive. Neptune is active. Neptune has the fastest winds in the solar system. Neptune generates more heat than it receives from the sun, radiating internal energy the way Jupiter and Saturn do. Neptune has storms that appear and disappear over years. Neptune is doing things that a planet this far from the sun should not have the energy to do. Something is driving Neptune. What that something is has not been fully explained. The planet that should be the quietest, the most frozen, the most still, is instead the most dynamic in the outer solar system. The furthest planet is also, in many ways, the most alive, and it will kill you faster than any planet before it. In this story, you are in Neptune's atmosphere. The sun is a bright point of light behind you. The wind is already moving, and you are at the edge of everything. Neptune is blue, not the pale cyan of Uranus, a deeper blue, a rich, saturated blue, the blue of deep ocean water on a clear day, the blue of something that has substance and depth to it. You are inside that blue right now. The atmosphere around you has the color of the deepest water you have ever seen, and you are suspended in it, surrounded by it, the blue in every direction. The color comes from methane, the same methane that gives Uranus its color. But Neptune's blue is richer, deeper, more saturated than Uranus's pale cyan, and nobody fully understands why. The methane content is similar. The atmospheric structure is similar. Something else in Neptune's atmosphere is producing additional blue absorption, something that the models have not fully captured. Neptune's color is partly a mystery. You are inside a mystery that is also a color in the daylight, such as it is, and with the sun a point of light 4 light hours away. The blue atmosphere has a quality unlike anything on the inner planets. The light here is dim, roughly 900 times dimmer than sunlight on Earth. But it is enough to illuminate the clouds. The white cloud streaks that cut across the blue moving at their impossible speeds, are visible. The blue of the deep atmosphere is visible. The whole scene has the quality of late twilight on Earth. Not full dark, not full light, but the specific dim clarity of the hour just after sunset. It is very beautiful. You let yourself think this. You are at the edge of the solar system, in the coldest place you have been since Saturn's rings, in winds that will do what they are going to do regardless of your opinion on the matter, and the blue around you is genuinely, specifically beautiful. The blue is the last beautiful thing. The wind is coming. The clouds above you are white methane clouds, stretched into long, thin streaks by the wind. They move visibly, not the slow drift of Saturnian ring material, or the gradual shift of Jupiter's bands. These clouds move across the sky fast enough that you can watch them travel. A cloud that is above you is not above you for long. The wind takes it and carries it, and in minutes it is somewhere else. The sky of Neptune is always changing, always moving, the fastest sky in the solar system. The wind arrives. You felt hints of it before. A push here, a pressure there. But the full wind, the main flow, the jet stream of Neptune's atmosphere, moving at 2,100 kilometers per hour, arrives with a completeness that removes all other information. There is only the wind. 2,100 kilometers per hour is faster than the speed of sound on Earth. Sound travels at about 1,200 kilometers per hour at sea level. The wind of Neptune moves faster than that. If you were on Earth, in this wind, the sound of the wind would not be able to reach you because the wind itself would be moving faster than its own noise. You are not on Earth. You are in Neptune. And the wind is moving you, not gently, not the sustained river flow of Jupiter's jet streams or the steady push of Uranus. This is violent. This is the wind doing what 2,100 kilometers per hour of dense cold gas does to anything in its path. You are in its path. You have been in its path since you arrived. The wind has been building around you, gathering speed in the upper atmosphere. And now it has you fully. You cannot fight it. There is nothing to fight it with. No grip, no anchor, no wall. You are inside a fluid, and the fluid is moving at a speed that has no reference point in human experience. Your body, which has spent its entire existence inside Earth's mild weather, is receiving information that it does not have established categories for. Wind at 2,100 kilometers per hour is not experienced as wind. It is experienced as force. Pure, directional, irresistible force. You move with it. You have no choice about this. The only variable is how you hold yourself inside the movement, whether you tense against it or release into it, whether you fight the speed or accept it. You release. And Neptune takes you. No one knows what drives Neptune's winds. This is the genuine mystery at the heart of the planet. Neptune receives almost no energy from the sun, 900 times less than Earth. At this energy level, the atmosphere should be nearly still, cold and dark and quiet, moving only slowly under its own weight. Instead, it has the fastest winds in the solar system. The energy is coming from somewhere inside the planet, but the internal models of Neptune do not predict this much energy output. Neptune is doing something that the physics does not fully account for yet. You are inside the unexplained thing. Between gusts, you look for the sun again. That it is still there. The bright point in the dark blue sky, smaller than any star you have seen used as a navigation point, brighter than any star that is not the sun. It is unambiguously the sun. You know it by the brightness and by the direction and by the fact that you know which direction to look. But it does not feel like the sun. The sun on Mercury was a presence. It was the defining fact of that world. The thing that everything else was organized around. The thing that was trying to kill you directly and immediately. You could not look at it. You could not be near it without negotiating with it at every moment. This sun is a point of light. It is providing almost no warmth. The temperature of Neptune's upper atmosphere is around -218 degrees Celsius. The sun is not warming it in any meaningful way. The sun is not providing enough energy here to significantly affect the temperature. Its light reaches Neptune and lands on the clouds and reflects back into space, and the contribution to Neptune's thermal budget is almost nothing. The sun is here, and it does not matter. This is a strange feeling. You have spent your entire life on a planet where the sun matters enormously, where the sun is the reason for the seasons and the weather and the time of day and the existence of life and the color of the sky and 100 other things. The sun organized your days. The sun was the clock that everything ran by. Here, the sun is an irrelevance. It is a bright star. It will rise and set as Neptune rotates, the same way it rises and sets on Earth. But its rising will not warm the day, and its setting will not cool the night in any way that is distinguishable from the rest of the dark cold. The sun rises and sets here, and the planet does not notice. You notice. You notice because you know what that point of light is. You know that 8 planets orbit it. You know that on the third one from it, the smallest one visible to the naked eye from here, there is life. And the life built cities and wrote books and sent spacecraft to this place, and one of those spacecraft told you everything you know about where you are. You look at the sun. It looks back with the indifference of a star. Earth is not visible from here without a telescope. The planet you came from, and the only planet in the solar system with liquid water on its surface, and an oxygen atmosphere, and living things in every ocean and every forest and every city, is too small and too dim to see with the naked eye from Neptune's distance. You are looking at the sun, and the sun is the only thing in this part of the sky that confirms the existence of home. The sun and the knowledge that there are things orbiting it. One of them is yours. You cannot see it. You know it is there. Triton is above you, Neptune's largest moon, and the strangest moon in the solar system, for a reason that has nothing to do with its surface or its atmosphere or its geology. Triton orbits Neptune backwards. Every other large moon in the solar system orbits its planet in the same direction that the planet rotates. This is what you expect. When a moon forms from the same disk of material that forms a planet, it orbits in the same direction. The disk was spinning. The direction of rotation and the direction of orbit match because they came from the same source. Triton orbits in the opposite direction. This means Triton was not formed with Neptune. It formed somewhere else and was captured. Something brought it close enough that Neptune's gravity took hold. Yet the capture happened billions of years ago, and Triton has been orbiting backward ever since. The moon that arrived from somewhere else and never quite fit in. A captured moon is a temporary moon. Tidal forces from Neptune are slowly degrading Triton's orbit. Backward orbits are unstable. Over time, hundreds of millions of years, the orbit will decay until Triton comes close enough to Neptune to be torn apart by tidal forces. It will become a ring system, the way Saturn's rings may have come from a moon that came too close. Neptune will have rings made from a moon that was never supposed to be there in the first place. But that is in the future. Right now, Triton is there. A sphere of rock and nitrogen ice. Its surface the coldest measured surface in the solar system, at -235 degrees Celsius. Geysers of nitrogen erupting from its south pole, shooting dark material several kilometers into the thin atmosphere. A backward moon with geysers orbiting the windiest planet, at the edge of the solar system. You look at it in the dim light. It is doing what it has always done. Going the wrong way. Still going. Triton is one of the candidates for a place that might have liquid water beneath its surface, the way Europa does. The tidal heating from Neptune's gravity as it slowly reshapes the orbit. The residual heat from when the moon was captured billions of years ago might be keeping something liquid deep inside. If there is liquid water inside Triton, and if that water has access to the right chemistry, then the most distant large moon in the solar system might have conditions that could support life. And a backward moon at the edge of everything, going the wrong way around a planet that shouldn't have the winds it has, might be harboring something alive in its interior. No one has been close enough to check. No mission has returned to Neptune since Voyager 2 in 1989. When Voyager 2 flew past Neptune in 1989, it photographed a storm, a large dark oval in the southern hemisphere. Scientists named it the Great Dark Spot. It was similar in some ways to Jupiter's Great Red Spot, a high-pressure storm system large enough to contain the entire Earth. The winds around its edges reached the highest speeds measured anywhere in the solar system. It was the dominant feature of Neptune's visible atmosphere. 5 years later, the Hubble Space Telescope looked at Neptune. The Great Dark Spot was gone. Not weakened, not smaller, gone. Disappeared completely. In its place, a new dark spot had formed in the northern hemisphere. Then that one faded too. Neptune's large storms come and go on timescales of years, appearing and dissolving in ways that Jupiter's long-lived red spot does not. The storms are real and powerful while they exist, and then they simply end. You look for a dark spot now. There may be one. The atmosphere shifts around you, and some regions are darker than others. The blue deepening in places to something almost black. The cloud structure changing where the pressure systems are strongest. Whether any of these darker regions is a full storm system, or just a variation in the clouds you cannot determine from inside the atmosphere. But you feel the pressure variations. The wind changes speed as you move through different atmospheric regions, and in some places it accelerates, the flow tightening and speeding up around some structure you cannot see. In others it slows slightly, the pressure easing. You are moving through the weather of Neptune, through the systems that appear and disappear over years, through the atmosphere of the most dynamic planet in the outer solar system. The weather here is not permanent. Nothing on Neptune is permanent. Even the storms that look enormous from outside last only years before they dissolve. You have been here for hours. The question scientists cannot answer about Neptune is the same question in a different form for every outer planet. Where does the energy come from? Jupiter and Saturn generate significant internal heat from slow gravitational contraction. Neptune does too, radiating about twice the energy it receives from the Sun. But the atmospheric winds of Neptune are faster than Jupiter's, faster than Saturn's, faster than anything, in an atmosphere that receives almost no solar energy and should by all rights be nearly inert. Something inside Neptune is releasing energy into the atmosphere at a rate that physics does not yet fully account for. You are being thrown through the sky by energy that science has not fully explained. You are inside the question. You are at the edge of the solar system, not the physical edge. The physical edge is much further, out past Pluto and the Kuiper Belt, out where the Oort cloud extends, out where the sun's influence finally gives way to the influence of the galaxy. But Neptune is the edge of the ordered solar system, the last large planet, the last major gravitational presence. Beyond Neptune is different. Beyond Neptune, the objects get smaller and more numerous and more scattered, Pluto and its companions in the Kuiper Belt. Then the slow thinning of the Kuiper Belt into the scattered disk. Then the Oort cloud, a vast spherical shell of icy objects surrounding the solar system at enormous distances, so far out that some of them take millions of years to complete a single orbit. Then interstellar space. Neptune is the last sentinel. At the last planet standing between the solar system's interior and the emptiness beyond. You think about what that means for a planet. Every planet you have been to was surrounded by the solar system. Mercury was close to the sun, close to Venus, close to Earth. Mars was between the inner and outer planets. Jupiter and Saturn were in the middle of the outer system. Uranus was getting further. Neptune is at the edge. From here, you look inward at the solar system. The Sun and its 7 other planets are all in one direction, one half of the sky. The other half is the outer solar system, the objects that orbit beyond Neptune, and beyond them, interstellar space. Neptune lives on this boundary. Every orbit it completes brings it back to the same position at the edge. For 165 years, for billions of years, the last planet, always at the edge. They're always looking inward and outward simultaneously. The wind takes you. The edge does not care that you are here. Neptune was discovered in 1846, not by observation, but by mathematics. Astronomers had noticed that Uranus was not moving exactly as expected. Something was pulling on it. They calculated where the something had to be in order to produce the observed wobble. They pointed a telescope at that position in the sky. Neptune was there, a planet found by predicting it before seeing it, the mathematical ghost of an unseen planet, made real by a telescope. The solar system revealed one of its members through the behavior of another. Neptune announced itself through absence, through the mark it left on something else, before anyone had ever seen it directly. The cold of Neptune is different from the cold of Uranus. They are close in temperature. Neptune's upper atmosphere is around -218 degrees Celsius, slightly warmer than Uranus's -224. By any human measure, the difference between these numbers is not meaningful. Both are cold enough to freeze nitrogen. Both are cold enough to destroy any biological process. Both are far past any temperature a living thing can tolerate. But the cold feels different. Uranus's cold was still. It was the cold of a dark pole in a 42-year night. It had been accumulating in the absence of any energy source. It simply sat in the dark atmosphere and pressed inward from every direction. A passive cold. A cold that was there because nothing had warmed it. Neptune's cold is active. The wind carries it. The wind at 2,100 kilometers per hour takes the cold and drives it into you with force. Not just the temperature of the surrounding air pressing against you, but the temperature being delivered at speed. The kinetic energy of the wind, turning the cold into something that hits. Every gust is cold arriving at velocity. Every sustained flow is the cold sustained at velocity. The atmosphere of Neptune is cold the way a polar blizzard is cold, where the temperature and the wind combine into something more than either alone. You have been in this for hours. Your body has been making decisions for hours, prioritizing, rationing, the specific biological triage of an organism under sustained extreme stress. They'll be deciding what to keep running at full capacity and what to reduce, what to protect and what to let go. The hands went first. The feet followed the face. The cold of Neptune is working inward from the outside with the efficiency of a system that has been doing this to things for 4.5 billion years and knows exactly how. There is ice in the interior of Neptune. Not ice the way you think of ice, not the frozen water of a glass left in a freezer. The ice of Neptune's interior is water and methane and ammonia under pressures so extreme that these substances become something that is technically solid, but behaves in ways that solid materials on Earth do not. Scientists call it superionic ice. In superionic ice, the oxygen atoms lock into a crystal lattice the way they do in ordinary ice, but the hydrogen atoms move freely through the lattice like a liquid. The result is a material that is simultaneously solid and liquid, a crystal you can flow through, at a lattice that conducts electricity. The deep interior of Neptune may be an ocean of this substance, moving, conducting, carrying the electrical currents that generate Neptune's magnetic field. You are above an ocean that is solid and liquid at the same time. In 1989, a spacecraft flew through this place. Voyager 2. Launched in 1977, it had already visited Jupiter, Saturn, and Uranus. on what NASA called the Grand Tour, a trajectory that took advantage of a rare alignment of the outer planets that would not recur for another 175 years. Neptune was the last stop. The encounter lasted about 6 hours. 6 hours to see everything. The cameras photographed the atmosphere, the clouds, the great dark spot. They measured the winds. They photographed Triton and its geysers and its backwards orbit. They measured the magnetic field and the internal heat and the ring system that nobody knew existed. 6 hours to collect the data that would define everything humanity knows about Neptune from close range. Then Voyager 2 continued past. It is still out there, moving away from the solar system, and more than 20 billion kilometers from the sun now, in the space between the solar system and the nearest stars. Still transmitting, still sending back data. The signal takes more than 20 hours to reach Earth. The spacecraft that visited Neptune is now so far away that it is beyond the influence of the solar wind, in the space where the interstellar medium begins. Voyager 2 left Neptune and never came back. Nothing has come back. No mission has returned to Neptune since 1989. The planet that Voyager 2 photographed for 6 hours has been alone out here for over 30 years, doing what it does, generating its mysterious winds, losing Triton orbit by orbit to eventual destruction, maintaining its deep blue color and its internal heat, and the storms that form and dissolve over years. Alone. Except for you, for a few hours. And the data from Voyager 2's Neptune encounter took about 4 hours to reach Earth. The spacecraft sent its signal, and then waited. If a spacecraft can be said to wait for 4 hours while the signal traveled inward at the speed of light through the emptiness of the outer solar system, past Uranus and Saturn and Jupiter and the asteroid belt, through the inner solar system, to the dishes of the deep space network waiting on Earth. The scientists who received the signal had already accepted that they could not have a conversation with the spacecraft. They sent instructions that took 4 hours to arrive. The spacecraft executed them. 4 hours later, the results came back. A dialogue conducted across 8 hours of light travel time. The most patient conversation in human history. The wind has taken you a long way. You do not know how far.
Direction stopped being meaningful some time ago, carried away by the 2,100 km/h flow that does not consult your preferences about where it goes. You are somewhere in Neptune's atmosphere, deeper than when you arrived, the blue around you darker and the pressure greater, and the temperature at the level where the body's remaining systems are running on reserves. The clouds are different here. Higher up, the clouds were white methane streaks, bright against the blue. Deeper, the clouds are different compounds at different pressures and temperatures. The specific chemistry of a gas giant's interior atmosphere, changing as you go down. The blue deepens, the clouds thicken. The light, dim to begin with, is now very dim, filtered through layer after layer of atmosphere. The wind is different too, not slower. Neptune's winds are at their fastest in the upper atmosphere. Deeper, the atmospheric density changes the wind's character. It is still fast. It is still carrying you. But the air is thicker now, and the thick air has more mass behind each gust. The force of it different in quality, heavier, more present. The pressure in your ears is large. Your lungs are working against the increasing pressure with decreasing efficiency. Each breath harder than the last. Each breath returning less oxygen to the blood that is asking for it. The blue. The blue is extraordinary at this depth. You are surrounded by the deep blue of Neptune's interior atmosphere, the blue that is deeper than any ocean, deeper than anything that has a name on Earth. The specific blue of a planet that chose this color for reasons science has not completely explained, and that holds the color throughout its atmosphere, from the upper clouds to wherever the atmosphere ends and the interior begins. You are inside the color. You have always been inside it. The blue has been around you since the first moment you opened your eyes here. It will be around you at the last moment too.
Neptune has been in its current orbit for about 4.5 billion years. In that time, it has completed roughly 27 orbits around the Sun, 27 trips around the solar system at a distance that makes Earth's orbit look like a tight circle. 27 years that lasted 165 Earth years each. And in those 27 orbits, the planet has changed very little. The color is the same. The wind is the same. The internal heat is the same. Neptune does not appear to be evolving toward anything different. It is what it is, and it will be what it is for billions of years more. You are inside something that has been the same for longer than life has existed on Earth, and will remain the same for longer than life is likely to continue. You look for the sun one more time. From this depth in the atmosphere, it is harder to find. The clouds above you have thickened, and the light filtering through them is very dim, the blue-gray of a deeply overcast day, but darker. The overcast in question being hundreds of kilometers of methane and hydrogen, rather than the thin water clouds of Earth. But through a gap in the clouds, for a moment, you see it, the bright point. The light that left that point 4 hours and 10 minutes ago is reaching your eyes right now. 4 hours and 10 minutes ago, that photon was inside the sun, or just leaving it, beginning its journey outward through the solar system. It passed Mercury in the first 3 minutes. It passed Earth at the 8-minute mark. And it continued out through the asteroid belt and past Jupiter and Saturn and Uranus and finally reached Neptune and entered the atmosphere and filtered down through the clouds and reached your eyes. A 4-hour journey to land on your retinas. And now the photon is done. It has reached the end of its path. It entered your eye and triggered a response in the cells there and became part of your perception, and that is the end of it. The sun sent out that specific photon 4 hours ago, and it has arrived. The sun is still sending photons. The ones leaving the sun right now will reach Neptune in 4 hours and 10 minutes. You will not be here to receive them. The gap in the clouds closes. The bright point disappears. The blue closes over the place where the sun was. And you are inside Neptune's blue, completely, the wind still moving at 2,100 kilometers per hour. The cold still working inward. The pressure still climbing. The sun is out there. You cannot see it anymore. But it is out there, still burning, as it has always burned. The solar system will not last forever. The sun will change over the next 5 billion years, expanding as it ages, eventually becoming a red giant large enough to engulf Mercury and Venus and possibly Earth. The outer planets will survive this. Neptune at 4.5 billion kilometers will be far enough from the expanding sun to remain intact. It will be warmed somewhat, its atmosphere changed by the increased energy, but it will survive. Neptune may be the last planet still recognizable as a planet when the sun's active life ends. The furthest planet may outlast all the others, still blue, still windy, still mysterious, orbiting a dying star at the edge of a solar system that has been running for 10 billion years. The cold has reached the last places, not dramatically. Neptune does not do drama the way Jupiter does, the way Venus does. Neptune is thorough. The cold has moved through you with the same patience that the wind moved through you. The same patient application of physics to the problem of you being here. The wind is still at 2,100 kilometers per hour. The wind will be at 2,100 kilometers per hour long after this moment. The wind was at 2,100 kilometers per hour before you arrived. The wind of Neptune is not a response to your presence. It is not affected by your presence. It is a feature of the planet that predates you and will continue after you. You moved through it for a few hours, and it did not notice. This is the truth of Neptune. This is the truth of all the planets. They are not hostile. Hostility implies awareness, implies a relationship between the thing that is hostile and the thing it is hostile toward. Mercury did not try to burn you. Venus did not try to crush you. Mars did not try to freeze you. Jupiter did not try to swallow you. Saturn did not try to absorb you. Uranus did not try to disorient you. Neptune is not trying to end you. They are simply doing what they do. The physics of each planet doing what the physics of each planet does. You arrived. You were present. You were moved through the same processes that move everything else. The same cold and wind and pressure and time that acts on every molecule of gas in this atmosphere acted on you. No differently, no especially, you were here, at the edge, at the last planet. The blue of Neptune is around you, and the wind is in you, and the sun is a bright point 4 hours away, and the cold has finished what it started. And Neptune continues. The way it has always continued, going around the sun, taking 165 years to do it, blue and windy and mysterious. At the edge, close your eyes. The blue was very deep. The wind was very fast. The sun was a point of light. You were at the edge of everything. A note of science. Neptune is the 8th and outermost planet in the solar system. It orbits the Sun at an average distance of about 4.5 billion kilometers, completing one orbit every 165 Earth years. It was not observed with the naked eye until 2011, when it completed its first full orbit since its discovery in 1846. Neptune's wind speeds reach approximately 2,100 kilometers per hour in the upper atmosphere, making them the fastest sustained winds recorded in the solar system. The energy source for these winds is not fully understood. Neptune receives about 900 times less solar energy than Earth, yet its atmospheric activity exceeds that of planets receiving far more solar input. Neptune is a deep, rich blue color. Like Uranus, methane in the atmosphere absorbs red light and reflects blue wavelengths. However, Neptune's blue is significantly deeper and more saturated than Uranus's pale cyan, suggesting an additional absorbing component in the atmosphere that has not yet been identified. The Great Dark Spot, observed by Voyager 2 in 1989, was a storm system roughly the size of Earth. When the Hubble Space Telescope observed Neptune in 1994, the Great Dark Spot had disappeared. A new dark spot had formed in the northern hemisphere. Neptune's large storm systems appear to be temporary features that form and dissolve over years or decades, unlike Jupiter's Great Red Spot, which has persisted for centuries. Triton is Neptune's largest moon, and the only large moon in the solar system that orbits in the opposite direction from its planet's rotation. This retrograde orbit indicates that Triton was captured from elsewhere in the solar system, most likely from the Kuiper Belt. Triton's orbit is slowly decaying due to tidal forces. In approximately 3.6 billion years, Triton will come close enough to Neptune to be torn apart by tidal forces, likely forming a ring system. Triton has active geysers near its south pole. The geysers erupt liquid nitrogen that has been warmed by the faint sunlight, shooting dark material several kilometers into the thin atmosphere. Triton's surface temperature is approximately -235 degrees Celsius, making it the coldest measured surface in the solar system. Voyager 2 remains the only spacecraft to have visited Neptune. It flew past in August 1989 and used Neptune's gravity to alter its trajectory and exit the solar system. Voyager 2 has since crossed into interstellar space and continues to transmit data. No follow-up mission to Neptune has been launched. Several proposals for an orbiter mission have been studied, and the scientific community has consistently ranked a Neptune system mission as a high priority for planetary science. Next, Pluto.